Okay, so 3.3 is the chain rule and the general power rule. Okay, so do you guys remember the chain rule from last year?
Yes.
A little bit?
Not really.
It's and the stuff at the end.
Oh, yep, exactly.
That's all I remember at the end.
Okay.
The stuff.
So the general power rule, okay, is used to differentiate a function of x raised to the power. Okay, so it's kind of like a chain rule. The only difference is a chain rule is going to have like a quantity that has an exponent. Okay, so if you can see this notation, this is kind of an interesting notation. Okay, so the basic rule that we kind of learned right here is you take the exponent, you multiply by the coefficient in front, and then you subtract one. The thing that's slightly different now is this times the u derivative. Okay, so the textbook that we use here calls this the hook-on factor. Okay, so the hook-on factor is the derivative of the inside. Okay, so this is the derivative, derivative of inside. Okay, derivative of the inside. Hook-on factor. Yeah, you're right. I called it stuff last year, didn't I?
You did.
Okay. So for question number 1, okay, you're going to start by deriving the outside. Okay, so you're going to kind of ignore the fact that I have some stuff on the inside, and you're going to derive the outside of it. Okay, so the 2 is going to go out to the front. Okay, my inside, I don't touch it, and then I lose 1 on my exponent. So what's my new exponent going to be? To the first power. Okay, then I have to multiply by my hook-on factor, which is the derivative of the inside. So what is the derivative of the inside? 2x. Okay, so that is the derivative. I could then simplify this. Okay, so when you're simplifying stuff with parentheses, you generally don't want to touch anything that has an exponential exponent. Okay, so like if I have a quantity that's to the second power, I'm never going to FOIL it out. Okay, I leave stuff factored. The only thing I'm really going to simplify is like the first term times that 2x in the back. Okay, so 2 times 2x would give me 4x. Okay, you could technically distribute this through because it's just a linear quantity. Okay, but it would be fine to leave it in that factored form as it is. Okay, you ready for number 2? All right, so question number 2, the very first thing that I notice is we have a square root, which we don't want to play with square roots, we want to work with exponents. Okay, so if I have a square root of a piece, what is that the same as? What exponent? What's that? 1/2. So do you notice how right now I already have a 3 in the exponent though? So if I have a 3 to a 1/2, I'm going to multiply those together. So what's 1/2 times 3? 3/2. So this is going to be to the 3/2. Okay, and now I'm going to do my chain rule. Okay, so chain rule is going to be, I'm going to derive the outside. So what's going to go out in front? Three halves, good. So 3/2, I don't touch the inside. Good, to the 1/2. And now I have to multiply by my hook-on factor. So what is the derivative of the inside?
4x minus 1.
4x minus 1.
Can't teach this.
Okay, so when I'm working with this, okay, again, I'm not going to touch the piece that's to the 1/2, but I could distribute the 3/2 through the linear quantity. So what I'm looking at is going from here to here. Okay, so what is 3/2 times 4x? So yeah, 6x. And then what's 3/2 minus 1? Minus 3/2.
Oh my gosh.
And then I don't touch this quantity that's to the 1/2. We just leave that be, and that's it. Not too bad? Okay. All right, now number 3. So this is one where we have two pieces that are being multiplied. Okay, the first thing I'm going to write is the cube root. So cube root is the same as, to what power? To the 1/3. Okay, so this is one where I have two pieces that are being multiplied. So this is going to be a chain rule within a product rule. Okay, so do you see that I have a first? So my first piece is the 3x squared, and my second piece is this quantity. So I'm going to do a product rule. Okay, are you ready? So product rule goes first d second plus second d first. So what is my first? 3x squared d second. So now when I derive the second piece, it's going to require me to use the chain rule to derive it. Okay, so when I derive this chain rule, what's going to go out front? The 1/2. So it goes 1/2. What? Oh, 1/3 because I wrote it down wrong. Thank you. Thank you for catching my mistake. 1/3. Whew. Okay. Inside stays the same. Okay, I'm going to lose 1 from the exponent, so 1/3 minus 1 is -2/3. Now I'm going to multiply by the derivative of the inside. So what's the derivative of 9 minus 4x squared? -8x. Good. Okay, so now remember, I'm still working on my product rule. So right now I have first d second. What comes next?
Second.
Plus second d first. So plus my second, I'm just going to rewrite my second. D first. So derivative of first, so derivative of 3x squared is 6x. Everybody okay with that? Will you guys all put your phones down? I can't tell if you're paying attention or playing a game. That would be awesome. Thank you. Okay, so simplifying this. Okay, so on my first term, you guys see my whole giant first term that I have? This piece all right here. Okay, remember I'm not going to touch anything that has a quantity with an exponent. So the only thing I can do with that to the -2/3 is put it into the bottom because it's negative. Okay, but I have to multiply 3x squared times 1/3, which by the way would be what? X squared, and then I have to multiply x squared times that -8x. So what's x squared times -8x? -8x cubed. So we're going to have -8x cubed. I'm going to put that quantity into the bottom, and the exponent turns positive. Okay, now on my second term, there's really nothing that I can simplify. I can pull the 6x in the front, usually put a monomial piece in the front, and then the quantity in the back. Okay, so nothing there, just make it look a little bit nicer. And that's as far as you're going to go. That okay on that simplification piece? Okay. All right, so the chain rule is basically the same as the general power rule. There is not really a difference. The chain rule is the idea of a composition. Okay, so a composition is if I take a function and I plug it into another function. Okay, so if I was, what? So if I was looking at, let's just say, question number 2, and I was doing maybe a composition on that one, I could say the function that I'm going to plug in is going to be 2x squared minus 3, and my big function would be x to the 3/2. Okay, so generally they're exactly the same. Okay, notice that the notation is slightly different. So instead of doing with u's, they have they use g of x's and f of x's. Okay, but it's really just derivative of the outside times the derivative of the inside. Okay, so let's try question number 4. Here's that same question that they're going to throw at us. Okay, so they give us a whole bunch of information that we're not going to read until after we do this piece right here. Okay, so we are going to do the derivative of p of q of x. Okay, so the first thing that I'm going to do is I'm going to derive p of q of x. Okay, so the derivative, and I'm going to write the notation correctly so you can see how this is. So the derivative of p of q of x equals, okay, so I have the derivative of the outside, so deriving the outside is going to be p derivative of q of x times what? What's the derivative of the inside? Derivative of q of x, good. Okay, so that's my notation. So now what I'm going to do is plug in the x, okay, and I'm going to go very slow on this. So I still have the derivative of d of x of p of q of 2 now. And every time I see an x on this step, I'm just going to replace it with a 2. So I have derivative of p of q of 2 times the derivative of q of 2. Okay, now I'm going to use that information from above. Okay, so the first piece that I need to find is the piece that's in the innermost parenthesis. Okay, so can you tell me what q of 2 is? Okay, so q of 2 is what? Q of 2 is 3. Everybody okay with where the 3 came from? Looking right here. Okay, now I could go ahead and find what the derivative of q of 2 is on the same step. Okay, so since I'm multiplying, what is the derivative of q of 2? 2, so that's this little piece right here. So times 2. Okay, and now I have one step further to go. I need to figure out what the derivative of p at 3 is. So what's the derivative of 3 at p, or p at 3? Do you guys see it? So looking, yep, right there. So we have 4 times 2, so it's 4 times 2. 8. Does that make sense, that little notation piece? No? What part did I lose you on? Was it the part that we were just deriving it? Or the plugging in part? So all of it? Yes, Tegan. How? Oh, so see how I have like parentheses and parentheses? So the first part is that I have to deal with the inside parentheses first. So I have to deal with this q of 2 first, and q of 2 is 3, so that's where I dropped from here.
And then you just do it again.
Yep, then I have to find the q derivative of my 3, which is 4. Okay. So there's no more on this. We could try to find another one of those on the assignment and do it. Do you guys want to do that?
Yeah.
Okay. 14. Yeah. Fine. Okay, yeah. Let's check out 14.
That's like
It's pretty far down there. Well, it's not a lot to write, so you could just watch and then when we get there, or just write at the top of your paper. It's up to you, though. So I did this once before. I'll erase it, though. Okay, so Garrett, are you ready? So check out number 14. Watch how we do this. So number 14, we have the g of x being the function is the inside piece, the f of x, to the third power. Okay, so then they give us this information that we're not going to look at until after we derive it, and then we'll plug it in. Okay, so first we're going to do the derivative of g. Okay, and we're going to derive it of x first, and then we'll talk about the 1 afterwards. Okay, so if I'm looking at the quantity of f of x cubed and we derive it, what would the derivative of that be using the chain rule? 3. My inside stays the same. What's my new exponent going to be? 2. And then times the derivative of the inside. So derivative of the inside is the derivative of f of x. Does that make sense?
Yes.
Okay, so now my second step is now I'm just going to plug 1s in. I'm not going to look at that information yet. I'm just going to rewrite the notation so it's all the x's are replaced with a 1. So f of 1 and derivative of f of 1. Let's row x. Okay, so now this is where I'm going to plug in that information. Okay, so the piece that I see on the innermost parentheses is f of 1. Do you guys see what I'm looking at? Okay, so f of 1, so looking right here. Okay, what is f of 1? 2. So I'm going to replace that with 2. Okay, and then I have times the derivative of f at 1. What is the derivative of f at 1? 4. Shoot, go away. 4. Okay, so now I'm left with all numbers and I can just simplify that. So I get, what's 12 times 4? 48? 48. That's it. Okay. Okay, so you guys have the rest of class to work on this assignment. If you get stuck, let me know so I can help.